Hi and welcome Year 9 students. Today we will be looking at how we can factorize quadratic expressions. You already know how to expand brackets. We've used FOIL to expand brackets. So let me give you an example just to refresh your memory of FOIL. Let's say we have something like this. And we expand it using FOIL. We get x squared. And then we get plus 3x, that's the outers, plus 1x, or just x, which is the inners, and then plus the lasts, which is 3. Now, and then we simplify that and we get x squared plus 4x plus 3. Now, factorizing is working backwards. What we want to do is work from this here and get our way back to this here. So how do we do that? Well, what you do is you know that this here is the result of this multiplied by this. So you look at all of the factors of that number. 1 times 3 and minus 1 times 3. Okay. Then you look at this number here, positive 4, and you go, what factors of 3 add to 4? Well, in this case, it's easy. It's 1 and 3, and so we can just go x plus 1, x plus 3. Now, it's not always that easy, as we'll find out. But I think what I'll do is I'll launch straight into this, and we'll do the examples that are in our book, and we'll learn a little bit of skill and intuition as we go along here about how to solve these. So, the first one we've been given here is x squared plus 7x plus 6. Now we've got to think of the factors of 6 that add to 7. Now we've got 1 and 6 and 2 and 3. Now obviously 2 and 3 don't add to 7, and they've already given us a clue that we need 6 and something else. So the other one must be 6 and the other one must be 1. So this one here is 1. Okay, the next one we have 15. Now the factors of 15 are, well, what are they? There's a few, but they've told us really what to expect because they said one of the ones that you want is 1. So to get 15, we'd have to have over here, I'm going to change this color so it's a bit darker, 1, 5. We'd need 15 here. 1 times 15 is 15. And then they would add together to give us this 16 here. The next one, we've got factor of 15 again, but this time one of them is 5, so the other one must be 3. So 5 and 3. Now, the thing is, 5 and 3 add to 8. Yep, so that works nicely. I'll use a thicker pen, I think. Okay, now this next one, we've got to look at this 20. We know that we've got a 5 here, so 5 times 4. So it should be 4. And what do we know? 5 and 4 add to 9. So that's really perfect. This next one, however, we've got a 6. We need factors that make, what are the factors of 6? So 3 times what? Well, it must be 3 times 2. And do 3 and 2 add to 5? Yes, they do. Let's move on. The next one, you'll notice here the change is that we've got a minus here and a plus here. That tells us that, so when you've got the situation with a minus here and a plus here, that tells us that we have 2 minuses making up this. A minus times a minus is a positive. So whenever you see x squared minus something x plus something, you know that you've got a factorized so that you've got 2 minuses. Okay, so factors of 8. Minus 2 times what is minus 8? Is positive 8? Well, it must be minus 4. Okay, and do those two add up to minus 6? Yes, they do. Minus 2 and minus 4 add to negative 6. Now let's move on. This time we've got a positive 15 and the factors must add to a negative 8. So minus 3 times minus 5 gives me minus 15, and they add to make minus 8. So that's helpful. That's good. We're happy with that. Next one, we've got a positive 4 and a minus 5. So we're looking at factors of 4 that add to minus 5. So we must have minus 1 and minus 4. They multiply to make positive 4. And they add to make minus 5. Then we have positive 8 factors of positive 8 that add to minus 9. And we've been given one of them, minus 8, so the other one must be minus 1. Minus 8 times minus 1 is positive 8. And they add together, minus 8 plus minus 1 is minus 9. The next one, we've got factors of that make positive 9 that add to make 6. So this must be 3 and 3, because negative 3 times negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. The next one, we've got factors that are of 6 that add to minus 5. So minus 2, the other one must be minus 4 because, oh sorry, my mistake, must be minus 3 because minus 2 times minus 3 is positive 6, and minus 2 plus minus 3 is minus 5 over x, is minus 5x. Goodness, losing it here today. Now, let's just refresh our memory, so let's do that one again. And see just if we can make sense of why this works. When we expand it, we get x squared, so that's FOIL, so this one. Then we go this one, outer. Then we go this one, inner. Then we go this one, lasts, which is positive 6. And we add those things together. So, what you see again is when we look at this, we find the factors of that add to this final number here. And you can see the factors like that. And then when you write those factors that add to that minus 5, you're going to get this scenario here. So hopefully it's kind of, it'll take a few goes for you to figure this one out. But hopefully it's starting to make some sense for you. And we're going to do a little bit more tomorrow on this as well. Let's go on to number 3. Again. This time we're just given pluses and minuses, so but we're not given the factors. So we're trying to add to positive 10 and factors of negative 11. Well, to get a negative number, you're going to have a positive and negative. So you could have 1 times negative 11 or negative 1 times positive 11. And you've got to decide which of these two is correct. Now, the way you decide that is you look at this here. Since we've got a positive here, when we add them together, it must be that the positive number must be higher. Because you can see minus 11 plus 1 would be minus 10. So we actually want this one here. So I think it should be plus 11. Oh, whoops, writing in the wrong place. Plus 11 minus 1. Same kind of idea with this next one here. What we're trying to achieve here is find the factors of 21 that add to 4. Now let's think of the factors of 21. We've got 1, 21, 3, and 7, and that's it. Now it's obviously going to be 3 and 7. We're trying to make 4. You can't make 4 from that one. And we're trying to make positive 4, which means we need a positive 7 and a negative 3. Positive 7 times negative 3 will give us this minus 21, and it will add to positive 4. So it should be 7 and minus 3. We're going to do the same thing again with the next one, except you'll notice that this time we have 2 minuses here. So this so the minus here tells us that the factors, one factor is positive, one is negative. The second minus tells us that the bigger factor is negative. Okay? So let's have a look. 35. So factors is 35. 1, 35. I think we can rule that out. The difference between them is not 2. Then the next one we can think of is 5 and 7. Oh, there we go. The difference between them is 2. And we need the bigger number to be negative. So positive 5 times negative 7 is 35. And the difference between them when we add them up is minus 2. So should be minus 7 here and positive 5 here. The next one, we have, we're trying to find factors that add to minus 21. Factors that make minus 21 that add to minus 4. So again, we're looking at 7 and 3. Okay, because 1 and 21 is too far away. 7 and 3, we want the bigger one to be negative. So it's going to be like that. Negative 7 times positive 3 is negative 21. We add those together, we get negative 4. So I think we want a 3 here, and we want a 7 here. Okay. Nextly, we are looking at factors of 60 that add to 32. So let's think of our factors of 60. 1 and 60. There's no way we can make those add to 32. That's not going to work. 2 times 30. That looks positive, doesn't it? 2 and 30. 2 times 30, positive 2 times positive 30, and then they would add to 60 as well. So that's nice and easy. The next one, we've got a minus 2. So, minus 2, factors of minus 2. So, and the add to negative 1. So we could do minus 2 times positive 1, or we could do positive 2 times negative 1. Now, when we have a negative here, that means we're adding to negative 1. So it's obviously this group here. So it's going to be that and that. Now we're moving on to the non-baby ones. We've got to do them on our own. So, 4a. X squared plus 9x minus 22. So for this one, I'm looking at factors of 22, negative 22, that add to positive 9. And the factors that I'm going to use are 11 and 2. 11 times negative 2. That works, doesn't it? And then 11 plus negative 2. So, got negative 22 there, and that equals positive 9. So that's what we want. So I'm going to go x plus 11 bracket x minus 2. And that would be the answer to 4a. Let's try the next one, b. This time we're trying to make factors of negative 12 that add to 4. Now, factors of 12 that add to... So I'm thinking 6 and 2 here, right? 6 times 2 is 12, and we can get them to add to 4. 6 times negative 2 equals negative 12. And 6 plus negative 2 equals 4. So that is definitely going to work for us. So we could go x plus 6, x minus 2. Let's move on to part C. Factors of 17. Well, it's a prime number, so that's nice and easy. And we need the factors. So the negative here tells us if we've got mixed brackets. So we definitely want minus for one. So x minus something. And we want a plus for the other. But we know here, because the bigger, when we add them together, we end up with a positive answer. We know that the bigger number must be positive, right? So we know that it must be 17 and 1, and the 17 must be positive. Whoops, that's not a 17. 17 times negative 1 equals negative 17. And 17 plus minus 1 equals positive 16. So that's what we want. So chuck in a minus 1 here, chuck in a 17 here. D. For D, we have x squared minus 8x minus 33. And I can see straight away that I'm looking at 11 and 3 here. And I think I want the bigger number to be negative, right? So the mixed, we must have mixed signs to get a negative answer, because a negative times a positive is negative. So 1 must be negative, 1 must be positive. Now, if you think about it, well, and they have to add up to a negative number. So that tells me that the bigger number must be negative and the smaller number must be positive. Otherwise, we wouldn't get a negative answer, right? So it should be something like this. Negative 11 times 3 is negative 33. And negative 11 plus 3 is equal to negative 8. So our brackets should look like this. X minus 11, x plus 3, like that. E. Now this one is interesting. We've got 24, so factors of 24. We've got a negative number here and a negative number here. So we've got different signs. So one bracket is going to have a negative and one's going to have a positive. And we've got to find factors of 24 that add to minus 5. And I'm thinking 8 and 3 here. So we've got an 8 and a 3, and we've got to make them equal to negative 24. And since we've got a negative 5 when we add them together, it must be a negative 8, right? Because negative 8 plus 3 is equal to negative 5. So I think we want minus 8 here and plus 3. Now, I'm just going to rub this out because I just want to finish with the last one on this page. What you'll notice about this last one is that it's actually the difference between two squares. We can ignore that because it's 0. So x squared minus 49, and we just go, oh, that's difference between two squares. X minus 7, x plus 7. And that's what we found last week we knew when we looked at difference between two squares. Well, team, I know this is a jump into a big new world. I know it's going to be hard for some of you, but we're going to take it slow. We're going to do some more of this tomorrow, and you're gonna nail it. Don't stress. If you do have questions or you're not kind of understanding something, let me know on ThinkWave. I know I pretty much raced through this, but don't stress. We're going to go over it. You're going to get it. All right then. Take care.